Good morning, sir.
Very good morning. Very good morning. Whether I'm audible?
Yes, sir.
Okay. We can start.
Okay. I will be starting the session now. Hello, everyone, and good morning to all. Dear authors and invited guests, welcome to Technical Session 5B. I am Dhimahi Patel, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 9th International Conference on Information and Communication Technology for Intelligent Systems, Bangkok, Thailand. The ninth edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Bangkok, and the virtual event is being held through Zoom for today and tomorrow, that is 5th and 6th April 2025. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 10 presentations, and each presenter will be given 10 minutes for the presentation and 2 minutes for the question and answers. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chair for this session. We have with us Dr. Yogesh Mali. Dr. Yogesh Mali is an associate professor at G.H. Raisoni College of Engineering and Management, Pune, India. With 11 years of academic and research experience, his expertise spans cybersecurity, IoT, blockchain, and artificial intelligence, where he has made significant contributions to advancing these fields. I welcome you, sir, to this session, and I request you to share a few remarks to everyone present here.
Yes, definitely. First of all, I would welcome all the participants and would say that it will be a great research journey and wish you all the best. And okay, fine then. Let's start with the proceedings.
Thank you so much, sir. Now we'll be starting with the presentations. Coming first up is Venkateshwara Rao Kodali. Sir, I request you to present your paper on a comprehensive survey on technological advancements in sustainable management of fisheries and aquatic ecosystems.
Good morning, ma'am. Good morning, sir. Is my voice audible, ma'am?
Yes, sir.
Okay. Shall I share my screen, ma'am? Is it visible, ma'am?
Yes, sir. Your screen is visible to us.
Okay. Good morning to everyone. Myself, good morning, sir.
Yes, good morning. Just put your screen presentation mode. Okay, fine then.
Okay, sir. Good morning to everyone. Myself, Venkateshwara. Today I'm giving a presentation on a comprehensive survey on technological advancements in sustainable management of fisheries and aquatic ecosystems. So this is about today's agenda for the paper. These are abstract and introduction, literature survey and problem identification and methodology, and finally outputs, and finally we have a conclusion. So coming to the abstract of this paper, nowadays everybody focusing on the exploration of the management of fisheries and aquatic systems based on some using advanced techniques for the problems what they are facing, like estimation of the fish sizes and reduction of the bycatch and fish counting. So for all this purpose, they are trying to using some advanced techniques. The interconnected areas like estimation of and bycatch reductions, fish counting plays an important role in the purpose of a population of the fish health and biodiversity conservation and supporting the economic viability. And the traditional methods what we have that can be drastically changed. Nowadays we have a many number of technologies are there, like a sonar and AI and underwater imaging, and drastically changed that traditional methods for fish development and pattern assessments in that. So actually in the aquatic ecosystem and fisheries management, the size estimation always plays a important role to improve the capture of the target species while reducing the capture of the bycatch, and need to identify the behavioral of those fishes and the mechanisms, and we need to every time monitor those. And for that purpose, we are adding some additional methodologies for automated imaging and EDN analysis and hydroacoustic technologies have aided. for counting of the fish and stock assessment. All these methods cannot be grouped together, but we can manage these modern methods for fisheries. And the purpose of all these methods for the purpose of curbing the overfishing and need to change the climate and putting of our humans desires in the balance in the underwater of ecosystem and promoting every time the better future. So this is about an abstract. And coming to the introduction, so we need to identify the fishes every time in the practical purpose of has a wider relevance, includes aspect ecology and aquaculture, biodiversity conservation. So totally we have, for example, 34,000 of known species of fishes living in the oceans, rivers, lakes, and bulk of waterable animals. They're important for the ecological balance of ecosystem, and we need to offer immense value of food and income and recreational activities. And every time we need to import and accurately, we need to identify the fish species for the fisheries and can be developed in a sustainable way. And we need to remember the biodiversity conservation and relationship with the aquatic systems, and we need to remember. So this is about an introduction. And coming to the literature survey, so these are the different papers surveyed for the purpose of this aquatic ecosystem and management of fisheries. These are the survey papers. And coming to the problem identification, especially I find out three problems are there. First, species identification, they are facing one of the difficult problem, and health monitor and behavior analysis of a fish is another one, and fish size estimation and bycatch reduction is a third one. So with these three for these three problems, I'm going to giving a some suggestion of a solution for the three problems using deep learning and machine learning technologies. Coming to the first one, that is species identification, and we need to every time remember the species identification about key points are like a biodiversity conservation and fisheries management, aquaculture development, and food safety traceability, and scientific research technological one. And second one is health monitoring behavior analysis of a fish. And we need to every time health of fish population is a key indicator for water quality and ecosystem stability. And we need to change such populations, temperature fluctuations, and habitat degradations. And effective monitoring not only ensures sustainability of fisheries, but also aids in early detection of diseases, and which can prevent the large scale of breakouts. The purpose of monitoring can be, on the other hand, provides valuable insights to the well-being of fish. Means that if the behavior of fish is not good, so we need to identify that something has happened. So we need to identify like the changes in the swimming pattern of those fishes and feeding behaviors and the social interaction of the colleagues of fishes, and if any diseases like we need to identify. And for that purpose, we need to use some advanced sensor technologies and computational methods such as computer vision. For this purpose, we need to use the computer vision and machine learning, have enabled automated and non-invasive monitoring of fish behavior and enhancing accuracy and efficiency. So we need to use sensor technology and some computational methods like a computer vision and machine learning technologies. And coming to the fish size estimation and bycatch reduction, every time we need to estimate the size of the fish is playing a vital role like for population dynamics. So like the traditional methods such as manual measurement lab, we need to use some labors prone to definitely we got some errors, especially in large scale of fisheries. So instead of that, we should use some modern technologies for fish size estimation through automated techniques like underwater imaging and photogrammetry, uses high resolution cameras that precise the measurement of fish length, width, and girth in their natural habitats. So these methods reduces the stress on fish by eliminating the need of physical handling. So because of that only we consider this. And coming to another contention, this kind of bycatch reduction means that we need to catch our target fishes only. So we don't need to catch the unwanted fishes. So for that purpose, during the fish operations, the significant ecological and economic challenges we are facing. For effective bycatch reduction, the strategies are essential for conserving biodiversity for fishing operations. So for that purpose, modern selective fishing gears modifications to fishing gears such as like a TED, turtle excluded devices we need to use, and bycatch reduction devices we should use, and some yes, size regulations use, and allow some non-target species to escape while training the desired catch. So here we are proposing one type of methodology for these three problems. Our goal is to create a strong framework that uses the combination of like detection, segmentation, and classification algorithms for the improvement of the accuracy for characteristics of fish analysis and health monitoring, using some cutting edge technologies like artificial intelligence, machine learning, and deep learning technologies, and to minimize the dimensionality of the data dimensionality and in the significant patterns what we are facing, the complexities in the data sets. So far we should use the PCA and the hierarchical cluster analysis. So from these comprehensive approaches, we are facing some key challenges like for fish size identification. We feel that a recurrent neural network with the transfer learning is good one for species identification, and for fish health monitoring, we suggest a convolutional neural network with integrated expert system. And for estimation of bycatch reduction, we adopt a computer vision based approach powered by deep learning algorithms. So these are the three methodologies so we are proposing for the three problems. And with this integrated methodology, to achieve the balance between the ecological conservation and operational needs of the fishing solution for the real world applications. So these are the comparison based models for the sustainable management of fisheries in the what I surveyed. So for species identification, the different others is RESNet and SMPPF models. So among these two, SPPF algorithm model gives a best accuracy and precision recall F1. So these are the evaluation metrics. So got a highest for the SPPF, and for fish health monitoring, MSRCR algorithm gives a best accuracy, and for fish bycatch reduction devices gives a highest accuracy and as well as precision recall and F1 score. So these are the visualization for the different models for evaluation metrics, for species identification, and for fish health monitoring, and for bycatch reduction. So finally, I conclude that this paper proposed for the managing the sustainable fishing methods, keeping an eye on maritime aquatic habitats and preserving species variety, and as well as the fish classification methods have evolved throughout the time due to advances in the computing technology with the deep learning models setting up the standards. Here what I'm saying is finally we are telling that whatever the three problems we identified, we are giving some suggested solutions for the like using of CNN with expert system and RNN with the transfer learning, and as well as computer vision based approach followed by deep learning algorithms. So these are the references I followed. Thank you, sir.
Okay, Venkateshwara.
Yes, sir.
First of all, I like the way you have given the analysis of fish, but I find something missing, that are what kind of diseases those fishes are having, or any type of
Yes, sir.
health.
We have a different. Actually, we have a different types of fishes. Species are there, like 40 to 50,000 of species identifications are there, sir.
Okay, fine. And how you are going to analyze them, because most of the fishes look nearly same.
Nearly same. Yes, sir. So we should use some we are using one data set, sir, like a fish whisper data set, sir, that containing like a 50,000 of fish species identification, and as well as a trait identification and trait segments are there. With help
Fine,
of that,
fine.
we can.
Whether you have collected that data set or you have downloaded from any website?
Yeah, I downloaded from the website, sir.
Okay, so suggestion for you would be there might be a data set which you have downloaded from the already available website might not have any outliers, might be a clean data set. So my suggestion would be you can take the photographs
Real
of
one.
the fishes, different fishes from the
Yes, sir. I'm
different.
trying, sir. Actually, nearby my house, we have a different fish ponds are there, sir. I will visit that and I will take some images of those fish species. Definitely, sir.
Okay, no problem. Fine, good work.
Okay, sir. Thank you, sir.
Yeah.
Thank you, sir, for your presentation. Now, next coming up is N. Krishna Chaitanya. I would request sir to present their study on a review of multimodal approaches in weather prediction and prototype development.
Thank you, Dimahi, for your kind intro. And happy morning, sir, and to everyone present here. Like, I would be sharing my screen now. Can you please confirm if my screen is visible?
Yes, sir, we can see your screen.
Good morning, everyone. My name is N. Krishna Chaitanya, and I am from Amrita School of Computing, Coimbatore. Before we delve into the technical aspect of my research, I would like to share a little personal story of mine, which have deeply motivated my work in this flood prediction problem. I was actually raised in my grandparents' home in a village named Jetprol, where I completed my primary schooling. And one day we experienced a devastating flood over there. And the rain poured continuously for whole 2 days, and flood water rose rapidly, and our electricity went out, and we have to temporarily have to move to some temporary shelters. And even our mobiles lost charge, and transportation was nearly impossible because roadways, transportation, everything was cut. And after a challenging and adventurous journey, we finally made it back home to my actual village, Nets, I believe. This experience, although it happened many years ago during my childhood, but it left a lasting impression on me. Like, I could say it sparked a desire in me to understand how exactly we predict floods, and how we respond to such natural disasters. And today we are gathered here to discuss how we can enhance and develop more reliable models that can actually and accurately predict floods and provide early warnings. That is what and region specific, I would say. And this is not just a technical problem. If we consider, it is a matter of saving lives and protecting communities as well. And with this motivation in mind, let's explore the research I conducted in multimodal approaches in weather prediction, specifically focusing on flood risk assessment. Moving forward, uh, here is the agenda for today's presentation. We will start with an introduction followed by problem statement, and we will see a what novelty and the literature survey, and we draw some inferences from it, and the algorithm, proposed algorithm, and finally the model architecture and its working. And we will conclude the session with the Q&A. And moving forward, like floods are most catastrophic natural disasters, causing significant loss of life and property, as we all know. And Chennai, especially, it experienced multiple major flood events, notably notably the 2015 flood, if you remember, which almost caused many lives and approximately more than 3 billion of economic loss. And our research aims to bridge this gap by using some of the techniques that we'll be seeing further. And if we see the uh, key challenges that we actually faced in this flood prediction, like is we right now overly rely on single source data, which is limiting the accuracy, I would say. Additionally, there is inefficient integration of temporal and spatial data, and current early warning mechanisms are also not tailored for the region specific. Like if we take Chennai, Like there are no particular models for that particular area. And our research question is, can a multimodal machine learning model enhance flood prediction accuracy and improve the response readiness for Chennai? Moving forward, throughout our research, we encountered several challenges, like data collection proved difficult, and particularly acquiring high quality spatial data, imagery, and sensor data also. And we face several other challenges in effectively matching the data types, the compatibility, and we initially started with the trial and error approach, I would say, and with the iterative testing to refine our models. Additionally, we dealt with the data incompatibility issues, like data must have the same size, and we have to retrain the whole model for one such case. And also a lack of existing approach in urban setting, and also proven a challenge to us. And moving forward to the proposed algorithm, the floodist consists of the algorithm named floodist consists of several key steps. We begin with inputting temporal and spatial data, and followed by the pre-processing to normalize and align the data that we can see. And we then extract the features using unit for spatial data and LSTM for the temporal data. And after fusing, we predict the flood risk probability there. And according to the probability, we classify it into high, medium, and low risk. And moving forward, uh, flood risk assessment has increasingly critical due to the climate change and urbanization, especially in the regions like Chennai. Our literature survey highlights the important research and has advanced methods and technologies in flood prediction, particularly through the combination of machine learning and multimodal techniques that we'll be seeing in detail in further. Moving forward from our literature survey, we infer the multimodal data fusion is essential to accurate flood risk assessment. And Gao et al. Highlighted the need for advanced fusion techniques, while Zhao et al. Demonstrated the effectiveness of deep learning architectures. Additionally, if we can see, the Khatri et al. Showcased the effectiveness of algorithms such as KNN, random forest, in identifying the flood-prone areas. And Berlin et al. Integrated the machine learning with process-based models for improved accuracy, and they were proven effective too. And these were a few of other papers that I referred through, and the findings and relevance that I gathered from this literature survey. And I'll be skipping this part and moving forward to the working and methodology of our project. Our model architecture consists of several key components. The unit architecture processes the spatial data using convolutional layers, while LSTM captures the temporal dependencies, as we already discussed. And the outputs from both encoders are concatenated in the fusion layer, as we can see here. And the final output layer produces the flood risk probability that we are discussing in the algorithm. And uh, and it will provide a quantitative assessment for flooding likelihood, I would say. And the third thing, like this was the VGG pre-trained classifier. Like what I intended to say is, we can obtain n number of models, and we can concatenate those vectors, and we can pass through the dense vector, like using the activation layer, like we be we'll be predicting the expected output. And moving forward, the results obtained from our prototype for estimating this using the integrating of multimodal data sources, like as we can see here, the model embeddings, this were the like as we can see in the result, this were the shape of the model embeddings, including the LSTM, ResNet, and VGG16. and the combined embeddings has be the followed up, and also the here the part B part, if we can see the output shows the flood risk prediction prediction model, which indicated high predicted probabilities for the flood event, because we inputted a vector which had a combined vector of which had flood, so we almost got a 99.6 probability. And however, we observed several limitations too, like the requirement of synchronized temporal and spatial data inputs is actually critical. But both they both must correspond to the same date and time, because we are just inputting the vectors. So if we give the spatial image of today and the temporal vector of yesterday, it also gives output, but this was one of the limitations, I would say. And moving forward, thank you all. Any questions?
Okay, Krishna Chaitanya,
Yes, sir.
I have a question for you.
Sir?
Have you tested your model with real-time data sets?
So actually, my data is custom made, sir. Like I web scraped images and I manually labeled them using semi-supervised and manual labeling thing. And
Okay, fine. Any real-time scenario as if you coming from the south region, whether most of the time the flooded are occurring in the Chennai and etc. side?
Yes, sir. Actually have tested we actually have tested it for the Chennai region with the real-time data, like with actual flood scenario and the temporal data, and combine the embeddings of that vector we have inputted to it, and this was the result that we obtained. And we have tested for several scenarios as well, not just but it was tailor specific for Chennai, because all the data that we train, the model is trained on is Chennai.
Okay, fine. Okay, good one. No problem.
Yes, sir. These were the references. Like I encourage you all to explore this for deeper understanding of a methodology that I followed. Thank
Okay,
you
fine.
all. Thank you.
Okay, thank you so much, sir, for your presentation. Now, next, I would like to call upon Kaja Mohideen, sir, to present their study on automated human action recognition using motion history mask-based convolutional neural network. Sir, can you hear me?
Yeah, good morning. Thanks, Dimari, for the introduction.
Good morning,
Am I
sir.
audible?
Yes, sir.
Yeah, thank you. Yeah, please let me share my screen. So, hope my screen is visible to everyone.
Yes, sir.
Yeah, thank you. So, initially, thanks for the organizer, right, for selecting our paper, and which is titled on automated human action recognition using motion history mask-based convolutional neural network. All right, this is a joint work supported by one of my student, Abhineshwari, and she's doing integrated MTech in our campus, right? Let's start with the abstract, right? So here we are proposing a model which is used to recognize the human action recognition from the video data, right? And this is a very old problem, right? So the people are you can find lots of research happening in this particular topic, and most of the people are uh, analyzing the video data by considering the whole pixel from the entire frame, right? So what we feel is like, so instead of considering the whole pixels or the complete pixels from the entire frame, so why don't we give more focus to the pixel which are active? Active in the sense, no, for a subject, we are typically we are looking for the action to be performed from the subject, right? So in that case, no, when it comes to video action, so the action will be done with the help of some movement, right? So that movement can be identified with a pixel uh, spatial location where the movement is happening rather than considering the static background and all. So we wanted to ignore those backgrounds by just giving a focus to the active pixels alone. In that way, we just investigated how this algorithm could work better for human action recognition, right? So we all know what does it mean by HAR. In short, it stands for human action recognition, right? So obviously, when you refer to the literature, so you could find lots of deep learning models and the transfer learning models have been applied for these kind of applications, and they have shown their significant advancement in by achieving the highest accuracy, right? So what we have this is a initial literature, right? So we have another plan in subsequent of this particular output, right? So but initially we wanted to test our approach for the video data. So whether no obviously when you consider the whole pixel from the entire frame, it automatically computationally it'll be more expensive, right? It'll be time consuming, right? So when you take any video data and if you wanted to analyze what action has been performed by the subject, right? So definitely the movement will be very limited to with some small bounding box rather than the movement is not at all going to happen for the entire frame, right? So in most of the cases, we are not generalizing it, but in most of the cases, the movement will happen only within the limited bounding boxes, not to the entire frame, right? So that's how we propose this idea, moving history mask based convolutional neural network for recognizing the human action. So we are here to construct the moving history mask first, and then based on the mask, we wanted to restrict the CNN operations, right? So we all know, right, what are all the fundamental operations we carry out in CNN. Obviously, the convolution, pooling, and other stuff, right? So when you take convolution, the convolution will be applied for each and every pixel of the frame, right? But here we wanted to restrict that the convolution operation it is enough to perform the convolution operation only to the pixel where the movement is happening, right? So for that purpose only, we are about to construct the moving history mask, right? And these are all the literature we study to come out with this idea, right? And most of the paper have used the LSTM or BiLSTM or the other flavor of CNN, ResNet, and even fuzzy logic, right? So most of the models are working with the deep learning ideas. It could be either a simple CNN LSTM or it can be a transfer learning approach, right? So, but as an initial approach, we have just started with CNN, right? So here, what is the one change we have made here is like, so we are going to explore only the CNN, but in that, before that CNN, we are going to estimate the motion history mask, right? So based on the mask only, we are going to perform the convolution and the CNN operation. So that is the very brief representation of the algorithm. So we don't want to discuss the CNN algorithm in much detail, right? So this is how we can generate the moving history mask, right? So we all know, right, the videos are collection of frames, right? So we take the first frame and the second frame, and we'll be doing the subtraction operation between these two. And based on the subtraction result, right, you could easily understand that which are all the portion the movement is happening or which are all the portion it is changing, right? And with one assumption saying that we assume that the background is static for all the video categories, right? So even when the background is also changing, this idea won't work, right? So the most of the video data what you have taken where we find only the static background, there it works perfectly, right? So this is how we do the subtraction. After the subtraction, it will be we check these or difference. If the difference is greater than the threshold value, then based on the threshold value, either we mark it as 1 or 0. So in that way, we'll be ending up with a binary mask. So the binary mask will looks like this, right? So this is going to be a kind of a binary mask, what we do, right? So this is one frame and this is another frame, right? It's a 10th frame. So just to take more differences, we have taken the first and the 10th frame of the video to easy to interpret what we are trying to explain, right? So after that, no, after the after finding the difference between each successive frames, and when you find the OR operation with all the differences, then this is going to be the final output what we get, right? So which are all the portion where we can find the difference, right? So this is the video actually the way the subject is playing the golf, right? So apart from while eliminating the background, these are all the only white pixels are talking about where the movement is happening. So it's better to restrict my convolution operation or CNN operations only to these particular pixels rather than considering the entire pixel. So that is your whole idea. So in that way, we are coming out with two different types of mask. Either it can be a rectangular bounding box mask or it can be a contour based fusion. So we'll be experimenting with these two different masks, and most of the time the results are going to be the same, right? So as I told you, we'll be experimenting with two different mask operation. Either that particular mask can be covered with the bounding box or it can be based on the region. It depends on the connected components, right? So as I insist, right? So this is the initial level research. So we have just taken the architecture which is well established, that is VGG60. So where we restrict the convolution and the pooling operations based on the mask. So that's why we have put every layer group has been accompanied with one mask. So depends on the input size, we'll be making use of different masks to restrict the convolution and the pooling operation, right? This is how you can rewrite the convolution and pooling operation and the ReLU operation results. The only changes, right? So where this is the up to this is the actual equation for performing the convolution operation, right? So where here we include another portion, right? So it is subjected that whether the pixel, if it belongs to the mask only, will be carrying out the convolution operation. Otherwise, we just retain the pixel assets. We don't apply the convolution operation for those pixels which are not part of the mask, right? So the same thing is applied for the max pooling operation also, right? And when it comes to the results and discussion, these are all the different data sets we experimented. We used to experiment our proposed idea. And this is how, this is what the result, what we have arrived, right? So when you talk about the recognition accuracy, right? So particularly, when you consider, right? So most of the algorithm out of, when you comparatively, our approach is performing better in terms of recognition accuracy alone, right? And this chart talks about how well it is performing based on the class, because each data set have different classes. When you consider UCF 101, there are 101 subjects playing different actions, right? So we just wanted to know how about the class based performance, right? The diagonal line talks about, is there any variable performance in that recognition accuracy based on the different subjects. And overall, our aim is to reduce the time, right? The complexity of the algorithm when it comes to training, right? So we have tested this particular proposed idea with our own personal laptop only, right? So which gives us that comparatively, when compared to the AlexNet or VGG16, the baseline algorithm, the time taken for completing one epoch is very much lesser, right? Okay. So recently we have in our campus, we have come out with the implementation of NVIDIA H100. It's a high effective GPU server, right? So we have a plan to implement or execute this algorithm in that particular server. Obviously, the time would be smaller than this thing, right? And one more thing is like, so I'll explain what is the actual idea behind this research is like. So, okay, so when it comes to the conclusion, yes, obviously this particular method gives better accuracy in human action recognition, and always it comes out with the better recognition accuracy in future, right? So we are planning to build uh, the campus surveillance system, right? So where we just wanted to monitor the human action recognition of the students and the staff members inside the campus. So we are placing the cameras everywhere, and we just wanted to collect the real-time data from those cameras, and we wanted to monitor what kind of actions is performed at every single subject, right? So this can be useful to monitor the entire campus without any manpower, right? So that is the overall idea of this particular uh, startup, right? So, but initially we have taken and investigated with the benchmark data set, and slowly we are right now we are doing the data collection. So the people are a small team of people are working in data collection. So after the data collection, once we get some enough number of data, then we'll be going for applying this algorithm with the real-time data, right? Yeah, these are all some of the back references what we have worked with to understand what is happening in the field. Now it's open for the
Okay.
question.
Good presentation, Mohiddin sir, and with your,
Thank you.
I guess, student partner Abhineshwari, if I'm not wrong.
Yes. Yeah.
Yeah. So let me know during the usage of CNN, mostly have you reduced the images or the videos to the grayscale?
Yes, sir. Yes.
Have you reduced to grayscale?
Yeah. Yes. Yes. We don't work with the color images. We reduce to the grayscale and then we work. Am I audible?
Yes,
Sir,
sir,
am I audible?
you are.
Yes. Yeah. Please.
I
I
think there
think
was a
there is
technical
some issue
glitch.
with the chair.
Yes, sir.
Oh, okay. No problem. Let me hold. Right.
Yogesh, sir, can you hear me?
Yes. Please answer the question. Sorry for the interrupt. Network issue.
No issue. No issues. Yeah. We convert the color into grayscale and we started processing with the grayscale images.
Okay, fine. Okay.
Yeah.
Last question.
Yeah.
Any
Please.
difficulty when you're working with real-time motions?
Yeah, the thing is like so as we are planning to work with the CCTV footages, there won't be any problem. That's because the camera is going to be fixed. But when we started working with the benchmark data set, no, the some of the time the background is also moving, not only the subject. So at that time we faced difficulties.
Okay, fine. Okay. Thank you, sir. No problem.
Yeah,
Okay.
thank you. Thank you, sir. Yeah, thanks for the
Thank you,
opportunity.
sir.
Thank you, Demari.
Now, next, I would like to call upon Ria Sapkale to present her study on automating tag prediction in Stack Overflow using machine learning and deep learning techniques. Ria, ma'am, are you here with us?
Yeah, yeah. Am I heard? Am I audible?
Yes, ma'am.
Hello? Okay. I'll be presenting my screen. Is my screen visible?
Yes, ma'am, we can see your screen.
All right. Mm, Okay. So, good morning, everyone. Today we'll be presenting our paper on the topic automating tag prediction in Stack Overflow using machine learning and deep learning techniques. The team consists of me, Riya C. Sapkale. I'll be the presenter. Pranav Acharya, Shreya Hegde, and Shreya Kiran. So, firstly, I would like to thank the ICTIS committee for the opportunity to present our research at this esteemed international conference. This research was conducted as part of the CDSML CCBD summer internship at PES University. So, I would like to extend my heartfelt gratitude to PES University, CDSML, the director of CDSML, and the Department of Computer Science and Engineering, as well as our guide, Dr. Ashwini Joshi. So this is the outline, and this is what I'll be covering throughout this presentation. So let's start with the problem statement. So Stack Overflow is a critical tool for programmers worldwide. It is a question and answer platform with over 100 million monthly visitors. The platform uses tags to categorize questions, with users able to assign up to 5 tags per question from over 60,000 unique tags. However, there is current limitations in the manual tagging system. Firstly, there is inconsistent tag application, human error in selecting appropriate tags, insufficient, inefficient search and discovery when the tags are missing or incorrect, and time-consuming process for all the users. Our research addresses this challenge by developing an automated system that can accurately predict relevant tags based on question content. So this is how the website looks like. There are questions, the body, and tags. As you can see, each question has at least one tag, and you can have a maximum of 5 tags. So here we can see how this process can become inefficient or incomplete or apply. The tags also determine the discovery of the given question. So it also matters to choose your tags very carefully. So the abstract and scope. Um, so what we have done in our research is we have made a hybrid deep learning based auto tagging system that leverage NLP techniques to automate and improve the accuracy of tag predictions. We're using data sets from Kaggle and Hugging Face and pre-processing them and applying models such as CNN, GRU, and a hybrid CNN GRU architecture. Our model has achieved over 81% accuracy on large data sets, which have outperformed the traditional ML and traditional DL models. The scope of our project focuses on predicting top 10 most frequent tags. Datasets are restricted to the English language, and we have evaluated on multiple ML and DL models. So the literature survey. We surveyed various papers, but like right now, we are only explaining 4 major papers. Here, paper one is automated question tagging using machine learning. This paper used models such as KNN and random forest to evaluate and automate the Stack Overflow process. Here, they did the data processing by data cleaning and normalizing the text, removing unnecessary characters by stop word removal and stemming words. As we can see here, they have extracted the top 100 tags and selected 1,000 positive samples and 800 negative samples for each tag, and then hence predicted the 100 most frequent words as features. Yeah. So paper two was enhancing user experience on question answer platforms by measuring text similarity based on a hybrid CNN and LSTM model. So here, this paper has used CNNs and LSTMs to identify the tags and getting high accuracy and as well as identifying duplicate questions. This paper has also used word embeddings such as Google's Word2Vec and Glove. So yeah. Now paper three was automatic question tagging using KNN and random forest. As we can see, this is another paper that is using traditional ML models. Here, they achieved an accuracy of 75% with the KNN, and the random forest classifier achieved 70% accuracy. They also use pre-processing steps such as stripping the HTML tags, removing numbers, punctuations, removing white spaces, tokenization, stop word removal, and stemming. Feature abstraction consisted of top 100 tags by frequency, where yeah. Then paper four was advanced automated tagging for Stack Overflow, a multi-stage approach using deep learning and NLP techniques. Here, the data pre-processing techniques were standard NLP pre-processing. The candidate tag extraction, however, was using Yake algorithm for initial tags and MPNet for question embedding, followed by multi-label KNN and multi-label random forest and cosine similarity for further tag extraction. They also used data cleaning techniques such as tag pruning and sorting based on a scoring system. Yeah. So the data sets we use here was Stack Overflow 2018 questions dataset from Kaggle, Stack Overflow tag production dataset from Kaggle, and Hugging Face's Stack Overflow post dataset. These are the datasets, and yeah, as we can see, this had a body, title, and tags. The second dataset only had title and tags, so we decided to eliminate it later on as it didn't have much context for the model to predict the tags. And in the end, we ended up using the Hugging Face model. As we can see, there are various columns, but in the end, we used questions, body, and the title. So here we combined all these. So yeah, for the dataset pre-processing, we combined all these columns into a questions column and we removed duplicates and handled missing data. We normalized these tags into structured lists and we extracted the 10 most common tags. We partitioned the data with an 80-20 split for training and testing, creating multiple data sizes 10K, 50K, 100K, and 150K to evaluate scalability. So, firstly, our approach was to evaluate the machine learning models. So, we started with the preliminary machine learning models. So, these included naive-Bayes, SVM, random forest, and KNN. For each of these models, we performed data preparation, model training, and evaluation. In data preparation, we collected the data set consisting their questions and associated tags, pre-processed the data by tokenizing the tags and converting into a binary format. Then we split the data into training and test sets. Then, yeah. So in the model training part, we trained each model on the training set and evaluated each model's performance on the validation set. In the end, we measured the accuracy, and most of the models had an accuracy of about 70%. As we can see, this is not very ideal, and has like high scope for improvement. So this is the um, bar graph for each of the data sets. And as we can see, dataset 4 is performing significantly well than the other datasets. So what we realized here was the dataset 4 was overfitting to a model. And then what we decided was to eliminate the dataset and use another dataset. Our next approach was to explore deep learning models. Here we used models such as LSTM and bidirectional LSTM, gated recurrent units or GRU, transformers such as BERT, CNNs, GAN, and RNNs. Again, we performed the data preparation, model architecture, and training and evaluation. So this was the accuracy we got. As we can see, the accuracy is still not very good. It's still in the 70 to 75 range, and there is high scope for improvement. Here we can see that the models CNN and GRU aren't performing really well. They have an accuracy between 60 and 65%. So what we decided ultimately was to use a hybrid deep learning approach. So this included um, making models with GRU RNN, GRU with CNN, GRU with LSTM, bidirectional GRU, and other hybrid combinations. And what we could see was GRU and CNN that gave us very less accuracy last time into the 60 and 65 range, gave us the highest accuracy when combined with an average of 76.1%. So what we decided was this will be a model and we'll further fine tune this model. So as you can see, GRU and CNN gave the highest accuracy. So this is just the bar graph. So so we selected our final models to be a hybrid GRU and CNN model as they perform better compared to the other models. And it gave a good balance of accuracy as well as computational efficiency. And yeah, so when we tested the model with other data set sizes, we saw that it performs significantly better uh, than the individual models. As you can see here, the 10K data set gave us a 70% average, whereas just on GRE or just on CNN, it gave us an only 33% average. And as we could see, the average accuracy increased with the data set size. So this meant that the model was scalable and expanding like the data set size would only give us a higher accuracy.
Excuse me,
So
ma'am.
yeah,
I'm sorry for interrupting, but this is a gentle reminder that you have crossed your 9-minute mark, and I would request you to
okay,
end your presentation in the time frame.
okay, I'll do that. So we'll just skip the architecture for now, and yeah, this is just the how the architecture is. And we use technologies such as pandas, TensorFlow, scikit-learn, NumPy, IP widgets, subprocesses, tokenizers, early stopping, and precision score. This was the model architecture. We used various layers, and as you can see, and we saw that the CNN layer uh, helped in recognizing the local patterns. This is the final accuracy, time taken, computational resources used. And this is how the data set increased its accuracy with the size. So our results were that the traditional ML models achieved moderate success, as well as the deep learning models. The issue with the deep learning models was that they had higher computational overhead, and that's why we chose a hybrid approach. It gave a good accuracy with a good computational time and space limit. And yeah, this is our conclusion. Our research successfully developed this hybrid CNN GR model for tag prediction, improved tagging and enhanced search and discovery. We achieved an accuracy of 81% on the larger data sets. And our future work will consist of expanding beyond the top 10 tags, further fine tuning, and incorporating more recent chart overflow data. These are the references, and thank you. Please let me know if you have any questions.
Yeah, Ria was a nice presentation.
Thank you, sir.
I am little bit, to be very honest, a little bit worried about the accuracy which you have got. Can you explain
Okay.
how accuracy is that much? Means the number is pretty high.
So we actually even tested it out with the code. So the accuracy is high because we're only extracting the top 10 tags. So since we are limiting it to the top 10 tags, if we ask a
Exactly.
query that is,
Yeah, yeah.
that is from the top 10
Continue,
tags, we
continue,
are
continue.
getting good. Yes.
Okay.
So if we ask a question from the top 10 tags, we are getting pretty good accuracy. It's still not perfect, but 81% is what we've got.
Why? Because we have done analysis over this same thing. We were only reaching to 70,
Okay, sir.
60 odd number. So you have taken the
Okay.
precise data. That's why 81 is also not a bad number in terms of this research.
Yes, sir. Thank you.
Yeah, fine. Good one. No problem.
Thank you, sir.
Thank you, ma'am, for your presentation.
Thank you.
Now, next, I would like to ask Sauresh Cornet to present his paper. Sir, are you here with us? I repeat, Sauresh Cornet. Sir, are you present with us? All right, we'll move to the next presenter. Amit Kumar Yadav. Sir, are you present with us?
Yes, ma'am.
Yes, sir. Please present your study on epileptic seizure classification on time series EEG signals using state-of-art learning techniques.
Yes, ma'am. My screen is visible, ma'am.
Yes, sir.
Our paper ID is 159, and the topic of our presentation is the epileptic seizure classification on time series EEG signals using state-of-art learning techniques. And the presenter is me, that is Amit Kumar Yadav. And other paper contribution is by Basir Alam sir and Ompal sir and Jyoti Yadav. And the agenda of presentation is divided into following parts, that is abstract, introduction, related work, research gap and contribution, data and processing steps, and result analysis. Later on, we have also comprised into the limitation and feature work, and finally the conclusion and references. In the abstract part, we have seen go through the different kind of literature survey and find out that the seizures detection is going to be very challenging, as it is going to be happen for a very short duration, and using the different kind of learning technique is going to be very helpful for us to get the diagnosis and detection of the seizure. So in this paper, we have analyzed the 10 machine learning model that is utilized in the different kind of papers, and we have altogether gather all the major one in this paper and find out the epilepsy detection on the bone time series is data set. And the evolution parameters utilized over here are the F1 score, precision, recall, and accuracy. And in the finding, we have found out that the random fluorescence and event-based demonstrate the higher performance. And in addition to this, we have also seen the impact of hyperparameter tuning and the feature recognition, and how the performance is get impacted by the on the models. And in the end, we have see that the machine learning is going to have a great potential for the detection and classification of procedures. In the introduction part, we have seen that the EEGs have a critical insight of the brain activities, and as we have the seizure is have a electrical interference with our brain, and so detecting from the EEG and find out of the and differentiating between the healthy and the seizure type of data, we have utilized the machine techniques, because EEG data is very complex and noisy, and it is very challenging to get the classification of this EEG data. So we have utilized, that is why the machine learning techniques that is utilized by different researchers over here. Some other the deep learning methods can also be utilized, but we have focusing our paper only on the EEG data set with the only ML techniques, and we have investigated the binary and the multi-class classification over here, and also done the feature restriction techniques and analyzes their impact also. In the related work, through the literature survey, we have find out that there are many type of learning techniques utilized by the different researchers, and in the recent study, the 8 classifiers are utilized. So we have to through this paper want to accommodate the this gap that all of the major machine learning technique can be utilized or seen by the decision in the one paper, so that they can utilize this in the further studies and improve the on the research analysis for the seizure detection. And the hybrid of the SPM also utilized by the another researcher, and the parameter optimization is also performed by them. And in by another study, we have seen that the gradient training boost algorithms providing the greater performance in comparison to others. And in the end, we have, despite this advancement, we have seen that the competitive performance of all of the major machine learning techniques are still not explored, and the feature restriction is not explored on the bone easy data set. So through this study, we come to and want to contribute this, to this paper, and the research gap that is we have found out that is not explored. So so this paper is going to provide the insight to the researcher in the field of epilepsy detection, and analyze the impact of all of the technique on the bone EEG data set. And this is going to be also helpful for providing the impact of process steps, hypertuning, and the feature extraction techniques on the ML technique. The data set we have utilized is the bone age data set, which have the 5 subsets, that is A to E, and A, B has the data of the healthy brain activities, and CDEs has the seizure-related activities data set, that is the interocital and acetal data states are captured over here. For this study, for the binary classification, we have utilized the A and E data set, and for the multi-class classification, we have utilized all the subsets, that's A to E. In the processing, pre-processing, we have shuffled the dataset for the unidentified patterns, so it can be removed, and the extended scalar function also utilized, so that the variance and the zero mean can be improved the model performance. And these are the some of the samples of the class A and E over here, so on screen. The result is analyzed through the various confusion matrix, so that we have the clear picture of what the actually our model is doing, and so that we can in later studies we can improve those things, and also give the clear picture to the other researchers how the models are behaving on this data set. So these are the different learning techniques, confusion matrix are shown over here. In the end, we have make the comparative analysis table for all the models, and we have found out that the RF and Navier base is providing the best accuracy in comparison to the other. And however, the logical regression or KNN and the simple models are not providing the good accuracy, as we have already seen that the EZ is a complex pattern, and these classifiers are not able to capture the that pattern efficiently. So they are getting the not good scores on this part. That is why. So we have seen the impact of these low performing accuracy classifier, how the pre-processing step get improved the performance. So we have seen that they have improved the without pre-processing the classifier is going to be have the less accuracy, but after pre-processing they provide the good increase in the performance. So there is a recommendation for the new researcher in this field. So they should apply the pre-process step for the model performance improvement. And in addition to that, we have also improved the accuracy or see the impact of hyperparameter tuning on all of the models. But we have seen that LR, CNNs, SVM, SDG, and DCT provide the better accuracy in terms of some of the best parameters that is shown over here. We have taken the for LR, we see the parametric value of C10 plus weight, balance, and penalty L to a solver live linear and give the good accuracy of 80%. And CNN best value parameter are met elucidation and neighbor is 3 and weight is distance. We will give the good parametric results. And as for SPM, similarly, the C is 1, gamma 001, and kernel RBF is good result. For SDG, alpha 0.1 and ETA 001, and learning rate optimal and max iteration 1000 give the good accuracy. And for the decision tree, the minimum split of 10 and maximum 5 and sample of IN criteria and would really give the good result. But the other classifier not give the improvement of by hypertuning the parameters result. So this is going to be better for the future result so that we can complete those in our future studies. And for the multiple class classification with only default parameter value, we have seen that the results on the different parenting value is not showing very good performance, and only extra tree is going to give the best result out of all the 10 parameters on parameter models. And so we have utilized the feature assisted techniques and captured the 18 features, 7 time domain features are utilized, 5 frequency domain, and 2 nonlinear, and 4 wavelet transform features are utilized over here. And the performance is increased very much after the feature extraction techniques, and only the feature extracted are utilized for the training, and the performance is then analyzed over here. Over here, the gradient boost is going to give the good accuracy, and the extracted also performance also increase over here. And top 10 features we have analyzed, and as per the feature importance from this 18 out of here is the Hurst exponent give the best feature over here, and beta is the second one. If
Excuse me,
we
sir.
yes ma'am.
I'm sorry for interrupting, but this is a reminder that you've crossed your 9-minute mark.
Ma'am, it is done. And the top 10 features we go through the 4097 pieces, the 101 and 4297 94 feature is going to give the good improvement. So in the limitation, we have only focused on the binary and the multi-class classification. So in future, we can go further and find out the multi-seizure types, that will focals, cellular absence, and clonic seizures also can be studied further. And deep learning techniques also can be integrated and find out over here. And in addition to the bone time series, other additional data set can also be explored in the future. So in the conclusion part, we find out that these state of techniques are giving the good result for the binary and the multi-class classification, and random forest and naive Bayes give the higher performance. Although this is going to be the very much improved by the hypertuning and the feature extraction techniques, and machine learning give the good potential for the detection classification. So in future we recommend and go for the work on our limitation and further improve our results using the other kind of techniques and as per your suggestion. And these are some references. Thank you.
Okay, Amit Kumar sir, from where did you got the bone EGG data set?
Sir, we have from their website of UGC University, we have downloaded the data set and we have accommodated their citation in the reference also. So they have given it is given on the fourth number of reference. So
Okay, okay.
yes, sir.
I got it. Now,
Yes.
what would be my suggestion? See, as if all your exit boot and etc. are giving pretty high accuracy and results.
Mhm.
So, whenever the data set is pre-downloaded from any source, it is clean,
Mhm.
structured, which is not having any outliers. So,
Mhm.
my suggestion for you would be contact some medical team, doctors, orthopedicians for getting such kind of actual data set where you are able to apply your own knowledge of hyperparameter tuning and etc. There you can see how your parameters and how your model is going to be working.
Sure, sir. And we in the future we are going to we will do the larger data set that is not such clean,
Lar-
so that we can
lar-
see the
yeah,
result in the real life, sir. Thank you so
larger
much,
is
sir.
not the concern. Larger is not the concern. Real time is
Hmm.
the concern. Why? Because
Y-
a pre available data set and you are applying your models will definitely give you the result. This is like
y-
you have already got a clay and everything is already pre ready. You are just coloring them. So
Okay, sir.
a sketch is ready and you are just putting your colors. So that
Okay, sir.
instead would be not a great research. What you
Okay,
can,
sir.
my suggestion would be go for real time data sets.
Sure, sir.
Yeah,
Thank you,
yeah.
sir.
Okay.
Thank you, sir. Thank you, sir.
Okay.
Okay, thank you so much, sir. Now, I would like to request Manasa R. Manasa ma'am, are you here with us?
Yes, ma'am.
Yes, ma'am. Please present your study on implementation of secure fingerprint voting machine.
Okay. Yeah, it's visible.
Yes, ma'am.
Yes, ma'am. Yeah, thank you. Good morning to one and all present here. I'm Dr. Manasa R, working as Assistant Professor Dayanand Sagar College of Engineering, Bengaluru. So my paper ID is 245. So implementation of secure fingerprint voting machine. So these are the contents. Coming to the abstract, the main objective of this study is to develop a secure and efficient biometric electronic voting machine. So that is an authentication system. So this system, actually, there is a combination of Arduino Uno, fingerprint modules, GSM modules, and LCDs to ensure that only eligible voters are allowed to cast their vote. The voting process begins with your fingerprint scanning of a voter, so which is then compared to stored records for identity verification. Once verified, an OTP will be sent to the voter's mobile phone for a second layer of authentication, ensuring a tool level verification process. So here, significantly, it enhances the security by preventing unauthorized voters. So the system is divided into two main components. One is master unit, which is also called as acknowledgement unit, and which is responsible for verifying the voter's identity and controlling the overall system. And the second component is a voting machine unit, so where the voter can cast their vote post, that is nothing but the post authentication. So the main key features of this system is it will include a instant vote counting and a there is a security measures as well. So, coming to the introduction, the main importance of elections in democratic country, we are well aware about that. So, elections are a fundamental part of our any democratic society. So, they are the representative of governance, like ensuring that citizens have the power to choose their leaders and make decisions regarding the country's future. So, elections are a means of giving people a voice in how they are governed, reinforce the values of democracy. So there are some of the challenges to voting integrity. So these are some of the challenges, as we can see, that is fraudulent voting and voter
Dr.
ineligibility.
Manasa,
Yes, ma'am.
sorry to interrupt. Your slides are not visible. Means they are not moving actually, and keep them
Okay.
in presentation mode.
It is in presentation mode, sir. Once again, I will try to put it in the presentation mode.
Make it full screen.
Yes, it's full screen. It's full screen, sir. It's moving, sir. Now.
Yeah, right. Right now it is moving. Okay.
Okay. Okay. So the main need for secure and transparent voting system is public. Usually, they trust the electoral process in which is directly tied to the fairness, transparency, and security. And this secure system is very important. And let us have an overview of biometric authentication. So here, fingerprint verification is very important for voting. So why we go for fingerprinters? Fingerprint are very unique to each individual, making them highly secure and easily verifiable. So they are commonly used in verification system due to their reliability and ease to use. So these
Manasa
are,
ma'am,
yes,
ma'am,
yes.
are you on your introduction page right now?
No, next slide. I have
Okay, ma'am, I would like to inform you that we can see your introduction page and
okay.
not your full screen mode. So can you please try
So
to share your screen again?
okay, ma'am. Okay, sure. Sorry for the inconvenience.
It's all right, ma'am.
Okay, now, ma'am, it's visible.
Yes, ma'am, we can see your slides, but it is not full screen view yet.
Okay, full screen I will do. Just let me know whether it's now. I'm in current issues in voting system.
No, ma'am, we can see biometric authentication and overview right now. Ma'am, are you sharing your full screen or just the
Yes,
window of the presentation?
it's a window.
Ma'am, please try to share your full screen so that it can go on with the slides that you change.
Okay. Okay, it's visible now, ma'am.
Yes, ma'am, please try. Yes, ma'am.
Okay, I'll just move this so it's visible. In presentation mode, maybe it's not going to the next slide. That's
Ma'am,
why.
please try presentation mode one last time.
Okay, it's visible, ma'am. Current issues in voting systems.
No, ma'am, your presentation mode is not visible.
Okay, so I'll just come out from the presentation mode and I will present like this only.
Yes, ma'am, sure.
Visible anyhow. Okay, thank you. These are some of the issues with which we current issues in voting systems. As we can see, we are going to we observe that there are voter fraud. So paper ballots are they are vulnerable to manipulation, including tampering and fraud. So there are errors in counting as well, because sometimes they'll do manual counting of paper ballots, which is very slow and prone to human error, which can lead to miscounts and misinterruptions of votes. So these are some of the issues which we lever voting machines. So complex operation, limited accountability, mechanical failure, and difficulty in recounting. So complex operation, we can say that like mechanical levers, which may not be initiative for all the individuals, particularly older or less tech savvy voters. So that time it is very complex for them. So limited accountability is like transparency in terms of vote verification or auditing. So mechanical failure can happen, breakdowns or technical failures during elections which can delay the voting process. So difficulty in recounting also. So these are some of the issues which we observe in which we see, which are the issues which we observe in voting system. So there are other common challenges like punched card system, voter confusion, and hanging or dimmed cards, consuming process, common issue across all systems. So these are some of the issues which we observe. Coming to the proposed system, so here we are going to see the authentication system for voting. The system is designed to use, here we are using Arduino microcontroller and various peripherals modules to ensure secure and efficient voting. The components of the systems, like we have here fingerprint module, keypad, and Arduino LCD display, GSM module, power supply, and the buzzer. So fingerprint module, here it is used to biometric authentication. Here we are going to scan the voter's fingerprint and compares it to a stored records to verify identity. And we have a keypad here. Keypad is allowed, it allows the voter to enter a pin or additional credentials for further verification. and comes the Arduino. The Arduino will act as a central control unit. So it processes the data from the fingerprint module and keypad and controls the interaction with other modules. Coming to the LCD display, we are going to provide the feedback to the voter, showing messages like fingerprint verified, OTP sent, and other status, which is updated during voting process. And also we have a GSM module. So it is responsible for sending the one-time password OTP to the voter's mobile phone for additional verification, and a power supply, which will ensure the entire system receives the necessary electrical power to operate the efficiency. And also we have included a buzzer over here to provide the feedback, alerting the voter of successfully or failed action if there is any success or a failure, to intimate to the voter. So here we have the fingerprint based voting system. So this is with respect to, this is like a solution for a design to enhance the security, to accuracy, and also efficiency to the voting process. So here the biometric authentication, that is fingerprints, to verify the voter, it will identify, ensuring that only eligible voters are able to cast their vote. So main objectives of using this fingerprint based voting system is, we are going to eliminate the fraud, improve the transparency, and speed up the election process. And this is the algorithm which I have used for biometric voting system. So we are going, in the first step, we are going to have the fingerprint enrollment. This is the first step, is to enroll the voter's fingerprint ID before the voting process begins. So this data is securely stored for the future verification. Then coming to the second step, that is nothing but the voting process initiation is going to happen here. So after successful enrollment, the voting process will begin, and when the voter attempts to cast their vote, their fingerprint is matched with the previously stored fingerprint database to confirm their identity. Then third step is like, we are going to check the voting status. The system checks whether the voter has already cast their vote. If the voter has already voted, they are not allowed to proceed. So if they haven't voted yet, the system moves on to the next step. Then coming to the step 4, it is nothing but the OTP verification is happening over here. So the voter receives an OTP via the GSM module, which they must enter correctly to proceed with the voting process. So this serves as an additional layer for the security. So then finally, we have the vote casting. After successfully completion, both the fingerprint and the OTP verification, the voter can cast their vote. So the system then displays the result on the LCD once voting is complete. So these are the flowcharts for enrollment and system overflow. So here we can see in the figure 2. So we are going to start the process, and we are going to press enroll button, and we are going to enter the mobile number. Okay, enter the mobile number, and also we are going to have the verification. If there is any error, then it will return back, or else it will be successfully stored. Then coming to the flowchart system, here this is nothing but the methodology. So here the system will begin with the voting process. Then we are going to get the fingerprint. After getting the fingerprint, the data verification will happen. If it is already voted, then it will return back. If not, then OTP verification will happen, then the polling, then finally it will exit. So these are some of the hardware and software components used for the system. So hardware components, we have used a fingerprint sensor module, that is R307. So this sensor is used to scan and verify the voter's fingerprint for identity authentication. Then a LCD display, which is 16 cross 2. So this display shows instructions and feedback to the user during the voting process. And also a GSM module for sending the one-time password. A keypad is used here for inputting the any additional data if the user wants to give the additional data, such as pin codes or OTPs, for further verification. And a buzzer also, as I have already mentioned, for indicating the success or the failure. And a power supply, and we are connecting wires and jumper cables we have used here. And coming to the software, and Arduino IDE has been used for programming and control the entire system. And C programming has been used to manage the operations of the Arduino, and which is to the connected components. And a GSM library has been we have used that to handle the communication with the GSM module and to receive the OTP for the verification. And also a LCD library is used to display the messages for and also the user feedback. And serial communication is also being used for data exchange. So coming to the results and discussions, as we can see, we have two key images here from the testing phase of the biometric voting system for demonstrating the results of voting process and handling for multiple voting attempts. And here we have the voting results in in the, we can say that finally, after the count, we are able to visualize who has won. Okay, so INS has won, so that is a name given here. So it will display the results. So we have used user is trying to cast the vote again. If it is already voted, then we are going to get the message as already voted. So the use of fingerprints as a method of human identification has been trusted for over a century. So in recent years, advancement in automated biometric systems have made fingerprint recognition more accessible. So leading to its widespread adoption. So this system has been successfully implemented and evaluated, delivering consistency and substantial results. So the integration of the fingerprint image enhancement phase further improves accuracy and efficiency for the verification process. So these are some of the key features like fingerprint reliability, advancement in biometric system, and system performance improvement. So some of the future role in elections can be like public and institutional acceptance has to happen, and ideal solution for fair elections should be done, and we have to strengthen the democracy. So based on this overall conclusion is this particular system will provide a secure, efficient, and a trustworthy solution for elections, so reinforcing democracy values. So future work, as we know, Arduino, the memory is very less, so we can expand the memory to store the fingerprint modules, and also we can integrate a smart card over here, and for that we can have we can increase the security as well. So these are some of the references. Thank you.
Okay, was a good attempt, doctor. Uh,
Thank you, sir.
Actually, lots of research has been already done in this field, and people are trying to make it more secure and more sustainable. But
Yes, sir.
again comes the aspect of whether a common people would be able to use them in runtime because of the biometric. That is the efficiency of the device capturing all the biometric, whatever the notations of their fingers in runtime. So, have you worked on that? What is the response time of your biometric system?
Response time was immediate only, sir. That we didn't take much of delay. But the problem is only very less. As I told, as we have used Audito, only less data was fed to the system. We have not further. It can be improved for the. We can have the advanced processor and try to implement this technique. And it can be done. The only thing is the problem with the network issue. So if at all the network is fine, and the storage, during the storage and transmission for this of the data, all those things we can implement, sir.
Okay, as if you are seeing this particular unit, what is your target audience for this particular voting system?
Public, sir.
Public, that means you want to have a normal democratic government election through this system?
Yes, yes, sir. Yes, sir. They can
Then
implement. It can be implemented. We
it
can
for
have
an
this
idea, for an
biometric system.
proposed idea, it is good.
Yes, sir.
For the knowledge addition in your terms, I would say that most of the people have tried
Yes,
doing this for
yes,
in
sir.
a public domain, but they have failed. The reasons are whenever the fingerprint module is used for multiple times by multiple people in the same scenario, would not
Okay.
respond as good as what is responding right now because of limited number of data set. Second
Yes,
thing,
sir.
what about the probability in common domain who those who don't have fingers?
Okay. In that case, we can have other biometric features like eyes. Then we can have that, sir. Through eyes, we can have the voting aspect. Am I audible, sir?
Yes, yes, you are audible. You are audible.
Hmm. So in that case, we can do that.
Okay, okay,
Yes,
no
sir.
problem,
Thank you, sir.
no problem. Okay,
Thank you, sir.
yeah.
Okay, thank you so much, ma'am.
Thank you, ma'am. Thank you.
Now, next, I would like to call Gagana KG. Ma'am, are you here with us?
Yes, ma'am.
Ma'am, please present your study on link prediction in protein interaction networks for Alzheimer's disease and dementia using graph-based approaches.
Yes, ma'am. I'll be sharing my screen.
Could I get a confirmation whether the screen is visible?
Yes, it is.
Thank you, sir. So, a very good morning to everyone present here. I'm Gagana KG, and I'll be presenting our paper titled Link Prediction in Protein Interaction Networks for Alzheimer's Disease and Dementia using graph-based approaches on behalf of our team. So protein-protein interactions, they play a crucial role in disease mechanisms, drug discovery, and therapeutic interventions. Computational prediction of protein-protein interactions can help in understanding neurodegenerative diseases like Alzheimer's disease and behavioral and psychological symptoms of dementia. So our objective was to develop a graph-based model that accurately predicts protein-protein interactions in a neurodegenerative disease research space. So the existing approaches include the usage of graph convolutional networks for disease diagnostics, especially in case of image data, the usage of random watch worker for disease gene prediction using functional and topological features, the usage of inductive matrix completion for prediction of gene disease association, which also proved capability to identify new genes. Challenges included limited accuracy and the lack of generalization and high computational costs. So when it comes to our study, we use the OMM data source and also the IID data source. So OMM data source, which is an online Mendelian inheritance in man database, was used for identifying Alzheimer's disease and BPSD-related proteins. So UniProt IDs are those unique identification IDs for a certain set of proteins. And we use the IID database, which is Integrated Interactions Database, for obtaining the PPI data for the network construction. Our statistics include a total of 19,132 protein-protein interactions for two tasks, which include link prediction in the overall graph and also AD and dementia analysis. For the data fields, we have considered the UniProt IDs, the symbols, and also their interaction evidences, such as computational or experimental. So our proposed approach includes a GGSV link prediction model, which is a variational graph order encoder integrating graph stage for neighborhood aggregation, usage of a GCN layer for extracting global features, and also usage of GAT for attention-based node representation. And the advantage that this gives is the capturing of local and global interaction patterns, enhancing the generalization capability. Coming to the model architecture and implementation details, the entire model was developed by using PyTorch geometric. The graph stage layer encodes the node features and the GAT applies attention mechanisms to refine the embeddings. The GCN layers further improve the latent representations, and the variational inference introduces probabilistic reasoning. And coming to the training setup, with trials, we came to a conclusion to use binary cross entropy loss along with KL divergence and a dropout rate of zero point 0.4 to prevent overfitting. Now, coming to our architecture diagram, the first portion here represents the method that we have incorporated for creating our data set. So we have considered the keywords related to the diseases that we have considered for our study. And we have used the OMM database to further extract keywords and then use that in the IID website to get the protein-protein interactions. Further, we did EDA to identify the key proteins and the node features. This later went to the GGSV link prediction model, where we considered a graph convolutional layer for initial encoding and another layer. After that, we have used a GAT layer for attention-based aggregation, and then two GCN layers based on trials. And we have concluded that two layers perform better for our data set. This
Later, our model also includes parameterization block, a decoder, and also optimizer to predict the links. Coming to our results, so our first task was link prediction for the entire graph considered as a whole. The performance performance metrics included included metrics such as train accuracy, test accuracy, and we have achieved the highest test accuracy of 71.12%, and it outperformed other models such as GraphSage, GAT, and GSEN for the dataset considered. We also ran epoch analysis, and we have found out that the best performance was achieved at epoch 150, with early stopping at epoch 363. The key insight is that a combination of GraphSage, GCN, and GAT in a variational order encoder architecture effectively captures local and global structures in PPI networks. So in the next slide, we have put up screenshots of our tables representing the analysis over different models, the performance analysis across different models, and also over epochs, and with respect to different hyperparameters values. Next, coming to the results with respect to our second task, which is Alzheimer's disease and dementia co-occurrence prediction. We have achieved an accuracy of 99.30%, but the other metrics show a suboptimal value. And the challenges we found out was that the precision and the recall require enhancement through better dataset balancing and model fine-tuning. Moving on to the conclusion of the future work, the key contributions introduced GGSV model combining GraphSage, GCN, and GAT for protein-protein interaction link prediction. We have achieved a high accuracy with respect to co-occurrence prediction in predicting PPIs and disease co-occurrences. The future enhancement would include improvisation and precision recall trade-off that we earlier saw for better disease prediction in real-time cases, to validate the results on larger data sets and also more diverse and balanced data sets, to integrate multimodal biological data for enhanced model performance, especially when it comes to Alzheimer's disease, which is focused on the memory region. And these are a few references that listed down. Thank you. Any questions?
Yeah, Gangna madam was a nice presentation. My question for you will be, for which data set you have used for Alzheimer's?
So we have used two different data sources. One is the OMIM, which is regularly updated. So the last time it was updated was on April 3rd, 2025. So this is almost a real-time data set. And what we have done is we have extracted particular IDs. So a total of 19,000 plus is what we have used as of now for our data set. But we believe that incorporating more fields and more fields and more features, considering our data type to be a graph, would enhance the capacity of our model.
Okay, fine. And how many epochs?
We have we have found out that total of 150 epochs was the best ability that the model could show.
Okay, fine. Okay, good one. No problem.
Thank you so much.
Okay, thank you, ma'am, for your presentation. Now, next up, I would like to call Navya Hola K, ma'am, to present her study on MIMO and SISO system BER analysis using DCSK and ODCSK modulation technique.
You, ma'am. I'm audible?
Yes, ma'am.
Actually, right now I'm traveling. So if any network issues, then please let me know in advance so that I can
Yes, ma'am. Sure, ma'am.
share the screen. The screen is visible?
Yes, ma'am. We can see your screen.
Morning, everyone. I'm going to give a presentation on MIMO and SISO system bit error rates analysis using DCSK and ODCSK modulation technique. These are the agendas. And when it comes to the abstract, the security nowadays is very important for the wireless communication. So for the security provided by the kiosk communication system, which is much superior compared to the other digital communication system. So that's the reason I'm going for the kiosk signal as a carrier, because it's formed into a new signal every time whenever the initial condition changes its value. And the modulation for this communication I'm using is differential chaos shift keying modulation for the based on the chaos, which use for gives a secured communication system. So this paper, it proposes differential chaos shift keying modulation as well as the orthogonal differential chaos shift modulation for MIMO and CISO system under AWGN noise channel. So as I told, so wireless communication in the previous days, they were using single input, single output communication system. But nowadays for the YG, for 5G or 6G wireless technology, we are using multiple input, multiple output communication system, multiple communication system under the AWGN channel. And as I told, I'm using kiosk, nothing but a noise. The kiosk as itself as a carrier, because it is a wideband, aperiodic, and unpredictable over a long duration. That's what I've told you. Like by changing the small initial values, it forms a new signal itself. So the receiver is not able to identify whether the received signal is a noise or any information signals. And as we told, there's a communication between transmitter and the receiver. There are two types of demodulation. That is receiver, where it's coherent or non-coherent. I'm using a non-coherent system because it does not require any carrier frequency, the same carrier frequency at the receiver side. And kiosk modulation is a differential phase shift keying and orthogonal. Let me explain that in detail on the next slide. This is a system overview, the methodology of the block diagram. So first is the input data, the message signals. For the modulation, we need a carrier. For that, we are using a kiosk generator to produce a kiosk, and that is transferring to a MIMO, means 2x2 MIMO. And the channel is AWGN channel, and the receiver is a demodulation technique, and the output message signal we are going to get. So first is the input data stream. So input data, input data stream. Input data stream, which is nothing but random signal, it is +1 and the -1 signal. And and the kiosk generator is nothing but it generates the kiosk, means it generates the noise itself. There are different mapping techniques are available. More than 120 mapping techniques are available. So in that I have used the logistic mapping technique, and there's a differential equation which is a non-linear. So this is the equation you can see, and where r, where this value is, we can change. For example, if the r value I have taken is 3.8. So if I make it 3.80001 also, a complete new form of signal only we are getting. You can see in the screen. So this is the noise signal, the kiosk signal for 3.8. So for 3.80001, for a small value variation also, it's a complete new form of signals we are producing. And if the R value is more than 3, so in that it is a more aperiodic signal characteristics we can obtain. So that I have done in the left hand side of the waveform. So next is the modulation. So modulation is a differential chaos shift shift keying modulation. So what is this differential chaos shift keying modulation means? For example, if I've taken the message bit as 4 message bits, 1010, and that message bit 1, which is divided into 2 slots. That is, if it is 0 to TB, so 0 to TB by 2 and TB by 2 TB. So that 0 to TB by 2, if the message bit is 1, the kiosk signal which is produced from the logistic mapping. So that, for example, if I take 20 kiosk signals, so that first 10 will be 10 will be sent as it is. That is the first half. And the next half, if the message bit is 1, the same signal will be passed. But if the message signal is -1, then what changes is, for the first half, the same kiosk signal will be passed. But for the next half, if the message bit is -1, then the reverse signal of that message signal of the kiosk signal will be passed. That's why it's called as a differential chaos shift keying. The 2 slots will be passed. So this is given as A of t, and or signal is M of c and M of t minus TB by 2. And if it is TB by 2 TB, If the signal is -1, then it is the reverse signal, nothing but minus of the previous signal will be passed. The same thing which I've explained just now. So first is chaos signal as it is 0 to TB by 2. And if it is TB by 2 TB, if the signal is 1, the same signal will pass. But if the signal is -1, then the reverse of the signal will be passed. That is +1 or -1. And this is for DCSK. If it is ODSK, only the small difference in the ODSK is instead of reversing the signal if the message bit is -1, the orthogonal signal of the first bit, it is by taking the Hilbert transform of the first half bits, bit in the next half bit. That is the orthogonal differentiation scheme. And channel is negative white Gaussian noise. So whatever I have sent my information is in the form of a noise itself, nothing but a chaos. So once again, the channel noise will be added. So that noise is again we have to demodulate. So for that, a correlator concept or equal gain combining concept I'm using. That is, at the receiver side, what is going to happen is, as we have divided, and I've told you the chaos signal is 20 chaos signal if I've taken, then the demodulation process is nothing but the first signal, the first bit and the 11th bit, that is the second of duration. The first bit and the 11th bit will be multiplied and will be added for the next one. That is second bit and 12th bit, then third bit and the 13th bit. So like that, each bits will be multiplied and be added. That is, you can see over here. So, sorry, yeah, here. So Rj of S and Rj of S plus S. That means first bit and 11th bit, then second bit and the 12th bit. Like that will be multiplied and which is taken as a summation. This is for the receiver 1. Again for the receiver 2. So those two receivers, whatever we are getting, so that will be added together finally. And it will be compared with the threshold value. If the threshold value, if it is greater than if the greater than the threshold value, then the value will be taken as a 1. Or if the value of threshold bit is less than of that value, then it is taken as a -1. So this is a signal. I have considered this for the only for the 10 bits. This is a message signal you can see. This is for the chaos signal 1. So I have produced two chaos signal as I told, 3.8 and 3.80001. You can see the complete new way of producing the signal. And this is of the modulated signal. So in this modulated signal, we can see at the receiver side, which is not able to tell at the receiver side whether this signal consists of the information. So which is a well secured communication. And at the receiver, I'm able to get back the original message. So this is only for the 10 bits I'm doing, so I am able to get it back. But for checking purpose, I've used 10,000 bits or 1 lakh bits I've taken. So in that cases, I'm going to calculate how many bits I've got at the receiver side. That is called as a bit error rate. So this is the orthogonal which I've done. So orthogonal also I'm able to get it. Since it is only for the 10 bits, I'm able to get it for the both the modulation techniques. So this is the result I've done for comparison of BPSK, that is the basic modulation technique, binary phase shift keying, and the DCSK for CISO, that is a single input, single output. Okay, so here I'm see the DCSK which gives a better output compared to the BPSK, and this is for MIMO, for 2x2 MIMO. So here also the DCSK gives a better compared to the BPSK. It is 10 to the power -4 I'm getting as a bit error rate. That is 10,000 bits of center. In that, how many bits I've got at the receiver side as a proper, that is a bit error rate. And this is DCSK and ODCSK. It is the orthogonal differential phase shift keying. In that, the orthogonal gives the better because of the orthogonality between the two bits. So that is gives better. So finally, what conclusion I yes.
Yes, ma'am, you've almost crossed your time limit.
Yeah, it's over, ma'am. It's over. So the conclusion is the bit error rate for the differential phase shift keying gives a better performance compared to the BPSK, and between DCSK and ODCSK, the ODCSK which gives the better bit error rate performance. These are the references. Thank you.
Yeah, Navya madam.
Yeah, yes, sir.
I can totally understand you are in traveling in India. It is time to reach to office. Same in my case. I am also traveling,
Yeah.
but the network supported, so no problem.
Thank you.
Coming back to your research, I just want to ask only one question.
Yeah. Yes.
The noise generator, if it generates the noise, how you can means regulate that? Any regulation of for those noises been done?
This one, no, sir. That was I said the logistic mapping. There are different mapping techniques are there, no, sir. So using that, I'm generating, and the receiver side, I'm trying with the different demodulation technique. Actually, this is the basic differential demodulation technique. So with the different demodulation technique, I'm checking, and in the different the demodulation technique only, I'm designing in such a way that I'm able to. I'm trying to get the message signal back at the receivers.
Okay, fine. Okay, and how you are able to capture each and every bit? Is there
That
any
I'm
missing of bit? Any
sorry,
miss-
sir. There any?
any missing of bit is been occurred? Sometimes this particular bit is missed, that particular bit is missed.
Yeah. Yes, sir. Yes, sir. That's what I have 10,000 bits I've sent in the form of ones and minus ones, sir. And in
Okay,
the receiver side, I'm not able to get it as a minus one. Instead of that, I'm getting some like zero or some other signals I'm getting. So those I'm have considered as a noise.
okay, fine.
Sorry,
Okay, no problem.
not noise as error. As error. Yeah.
Yeah. I got that. No problem. Fine.
Yeah.
I'm sorry. Next up is Martin H. Mole. Sir, I would like to call you to present your study on the role of corporate finance in enhancing entrepreneur innovation and performance. Martin, sir, are you here with us?
Yes, ma'am. I will share my screen now. Is my screen visible?
Yes, sir. We can see your screen.
Okay, thank you. Okay, I'll be presenting on the role of corporate finance in enhancing entrepreneurial innovation and performance. And these are my contents. We have introduction, research methodology, concept of entrepreneurial finance, entrepreneurial sources of finance, corporate financing, and conclusion with references. So this is my introduction. The introduction says that entrepreneurship and corporate finance have been combined in a rapidly changing global economy to create the drawback of innovation, growth, and sustainability. And during the first decades, entrepreneurship was understood as a business created by individuals who took up risk initiative on small scales. And in recent past years, also, the entrepreneurial model has also become more prominent in large corporations. So this is my research methodology. In this research, it was review literature was carried on, and it is a secondary research. So coming on to the next slide, here it says that entrepreneurial finance literature has been a significant change lately. Researchers have brought attention to the presence of sources of finance for individuals that were previously believed to be inevitable, like, for example, bank debt. Also, it has been brought to an urgency for a new changes like crowd sourcing. The latest tendencies necessitate a fundamental reconstruction of how entrepreneurs get capital and increase their businesses. So, talking about the entrepreneurial sources of finance, we're referring to operating a business or corporate finance company. An entrepreneur might embark on fundraising operations and to financially support the business. They can also access various funding sources because they are taking risks and innovating in new ventures. Entrepreneur desires to engage with external sources for rapid growth, regardless of whether they have internal funding sources for their company. From this perspective of financial researchers, entrepreneurship has long been viewed as a separate field of corporate finance. Then, talking about the sources, these are some of the sources of entrepreneurial financing. We have the personal source, grant and contest, family and friends, angel investors, crowdfunding, bank loans, corporate partnership, and strategic alliances, bootstrapping, and initial coin offering and cryptocurrency. So, corporate financing. Corporate finance is more concerned with the financial investment and decision made by the management of corporation to maximize the value of the wealth of company owners. However, because ownership and control are divided, managerial objectives are pursued at the expense of the shareholder. Financial managers make that make sense investment, financial planning, and dividend decision increase shareholder capital. And the board should also be actively and collectively reliable for the corporation for long-term performance. Here's my conclusion. The conclusion says that the dynamic relationship between entrepreneurship and corporate finance is essential to the creation of the modern business landscape. The current paper therefore shows how entrepreneurial finance is instrumental in providing innovation, growth, and sustainability for corporate ventures. Moreover, the introduction of diverse funding sources from personal investment to even sophisticated funding approaches like crowdfunding and ICOs may reflect an ever-changing form of entrepreneurial finance. And these are my references. Total references are 17. Thank you.
Okay, Martinson was a nice presentation. I would just like to ask only one question. What about the future scope? How you define your research in terms of future?
In the paper, it is not mentioned, the future scope is not mentioned in the paper. But in the future, entrepreneurs have a diverse understanding on how to raise funds and manage the corporation.
Okay, fine. Okay, no problem. Okay.
Thank you.
Okay, thank you so much, sir. Okay, before we end this session, this is the last call for Soresh Cornet. Sir, if you're present, please let us know. Okay, we'll start with the closing remarks then. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. And we, on behalf of the whole team, thank you for the support during this ninth version and all the previous 8 versions of this conference. We will be happy to have you in the 10th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. And further, all the papers have already forwarded to Sprinter. The publication will be live within 6 months, so kindly cooperate with the team of ICTIS 2025. I also thank our session chair, Dr. Yogesh Mali, for chairing the session. I'm presenting a token of gratitude on the behalf of Team ICTIS. Thank you, sir, for your presence, and I would request you to share any concluding remarks you may have for us.
Yes. At the outset, I would like to congratulate ICTIS for arranging this particular conference, and thank you for giving me the opportunity. It was really a knowledge gaining session. Every presenter present their particular research nicely, and I congratulate them and wish them a success in their future. Thank you.
Thank you so much, sir. Now, as we end this session, I would request everyone to switch on their camera for a quick moment to have a snapshot of the virtual conference. All right, thank you everyone. Have a great day ahead and see you all next year. Thank you.